Welcome to session 5, in which we talk about cabling, LANs, and WANs. Even though each LAN is unique, there are many design aspects that are common to all LANs. For example, most LANs follow the same standards and use the same components. This session presents information on elements of the Ethernet LANs and common LAN devices. There are several types of WAN connections. They range from dial-up to broadband access and differ in bandwidth, costs, and required equipment. This session also presents information on the various types of WAN connections that are available. So these are the session overview. The key topics will include cabling LANs, cabling WANs, and the reading list is shown. So each computer can be built with many different media types. The function of a media is to carry a flow of information through a LAN. Wireless LANs use the atmosphere or space as a medium. Other networking media confine network signals to a wire, cable, or fiber. Networking media are considered layer 1 or physical layer components of the LANs. Many topologies support LANs as well as many different physical media. Now, there are various symbols that are used to represent the media types. There's a token ring, is represented by a circle, the FDDI by 2 concentric circles, and so on. You get to see this when you reach the literature. Each type of media has advantages and disadvantages. And these are based on the cable length, the costs, the ease of installation, and then the susceptibility to what? Interference. Ethernet is the most widely used LAN technology. It was first implemented by Digital, Intel, and Xerox, the DIX group. The DIX created and implemented the first Ethernet LAN and specification. This was used as a basis for the Institute of What? Electrical and Electronic Engineers 802.3 specification. A network may require an upgrade to one of the faster Ethernet topologies. Most Ethernet networks will support speeds of 10 megabits per second and up to 100 megabits per second. There are several ways that Ethernet technologies can be used in a campus network. An Ethernet speed of 10 megabits can be used at the user level to provide good performance. Clients or servers that require more bandwidth can use 100 megabits Ethernet. Fast Ethernet is used as a link between user and network devices. It can support the combination of all traffic from each Ethernet segment. You can also use a fast Ethernet to connect enterprise servers. This would enhance client-server performance across campus network and help prevent what? Bottlenecks. A fast Ethernet is also referred to as what? A gigabit Ethernet and should be implemented between the backbone devices based on your affordability. The EIA-TIA specifies that an RJ45 connector for UTP cables. The letters RJ actually stands for registered jack, and number 45 refers to a specific wiring sequence. The RJ45 transparent end, that's a connector, shows 8 colored wires. You see this again in your lab sessions. 4 of the wires, T1 through T4, carry voltage and are called tip. The other 4 wires, R1 to R4, are grounded and are called a ring. We've been talking about crossover cable, but in a crossover cable, the RJ45 connectors on both ends show that some of the wires are connected to what? Different pins on each side of the cable. So you use a straight-through cable for the following connections: switch to router, switch to PC or server, hub to PC or server. And then you use the crossover cables for such connections such as switch to switch, switch to hub, hub to hub, router to router, PC to PC, and router to PC. My question, and I repeat this, I've asked this before, why do you use these particular types of cables for particular types of connections. Your answer must relate to the signals that are carried over the pins. Recall that pins 1 and 2 are used for receiving and the others are used for what? Sending. How do our repeaters work? In the olden days of telegraph, telephone, and microwave and optical communications, we use repeaters to strengthen the signal over long distances. In those days, what happens was that someone will stand on a hilltop, and people will be standing on hilltops some distance away, and one person will say something, then the next person hears that, will repeat that, for the person further to also repeat. So they call that what? Repeaters. So that term has sort of carried over. So a repeater receives a signal, regenerates it, and passes it on. It can regenerate and retime the network signals at the bit level to allow them to travel a longer distance on the media. Under Ethernet 802.3, there's a rule known as the 543 rule. This tells you the number of repeaters and segments on a shared access Ethernet backbone in a free topology. An Ethernet protocol requires that a signal sent out over the LAN reach every part of the network within a specified length of time. Hubs are actually multi-port repeaters. The difference between hubs and repeaters is usually the number of ports that each device provides. A typical repeater has only 2 ports. A hub, however, will have from 4 to 24 ports. Hubs are most commonly used for Ethernet 10-base-T or 100-base-T networks. The use of a hub changes the network from a linear bus with each device plugged directly into the wire to a star topology. So we use a hub, we've changed the distance from what? Linear to star. There are 3 basic types of hubs. There's the passive ones, active ones, then there's the intelligent ones. Devices attached to a hub will receive all the traffic that travels through the hub. If many devices are attached to the hub, collisions are likely to occur. Now, a collision occurs when 2 or more workstations send data over the network at the same time. Sometimes hubs are called concentrators, since they are central connection points for the Ethernet. Now, in terms of your collision, I want you to think again about what we discussed earlier in one of the earlier sessions about broadcast and tokens. Why tokens are used, and then in preference to a broadcast, why tokens are important. Because this has got to do with what? Collision. So wireless signals are electromagnetic waves that travel through the air. Wireless networks could use radio frequency, laser or infrared, satellite or microwaves to carry these signals between computers without any permanent cable connections. The only permanent cabling that we find with the access point for the network. At the core of wireless communications are devices called transmitters and what? Receivers. Now, there are times when it is necessary to break up a large LAN into smaller and more manageable segments. This decreases the amount of traffic on a single LAN and it can extend the geographical area past what a single LAN can support. Switches and bridges operate at the data link layer of the OSI model, that is at the layer 2. The function of a bridge is to make intelligent decisions about whether or not to pass signals on to the next segment of a network. When a bridge receives a frame on the network, the destination MAC address is looked up in the bridge table to determine whether to filter, flood, or copy the frame onto another segment. This decision process occurs as follows. If the destination device is on the same segment as a frame, the bridge will not send the frame onto another segment. This process is then called what? Filtering. If the destination device is on a different segment, the bridge forwards the frame to the appropriate segment. If the destination address is unknown to the bridge forwards the frame to all segments, except the one from which it has received it. This then is called flooding because it doesn't know where to send it, so it sends it to everyone. with the hope that one of them will say that it's theirs. A switch is sometimes described as what? A multi-port bridge. So here I'm looking at the various devices that you can use in a network. A typical bridge may have only 2 ports that link 2 segments, but a switch can have multiple ports based on the number of network segments that need to be linked up. Switches learn information about the data frames that they receive from computers on the network, so they are more intelligent. Switches use this information to build tables to determine the destination of data that is sent between computers on the network. Switching is a technology that alleviates the problem of congestion in Ethernet. Switches reduce the traffic and increase bandwidth. What are the functions of a switch? All switching equipment perform 2 basic operations. The first operation is called switching data frames. In this process, this is a process by which a frame which is received on an input medium and then transmitted to an output medium. The second operation is the maintenance of switching operations, where switches build and maintain switching tables and search for loops. When a LAN and WAN technologies are used, many computers are interconnected to provide services to their users. 2 computers will generally use request and response protocols to communicate with each other. One computer issues a request for a service, and a second computer receives and responds to that request. The requester acts like a client, and the responder acts like a server. So similar to in a peer-to-peer network computers can act as equal partners or peers. In a peer-to-peer network, individual users control their own resources. The users may decide to share certain files with other users. Peer-to-peer networks are relatively easy to install and operate. Peer-to-peer networks do not scale well, hence their inefficiency decreases rapidly as the number of computers on the network increase. And it's important to remember that individual users control access to the resources on their computers, which means security may be difficult to maintain. Generally, a peer-to-peer network will not work well for more than 10 computers, so they work better if the computers on the network is less than 10. Before a client can access the server resources, the client must be identified and authorized to use the resources. Servers are designed to handle requests from many clients simultaneously. In a client-server arrangement, network services are located on a dedicated computer that is called a server. The server is a central computer that is continuously available to respond to requests from clients for file, print, application, and other services. Each client is assigned an account name and a password that is verified by an authentication service. The authentication service then gets access to the network or to the server. Let's turn our attention to the physical layer of WANs. What is PTP? That's a point-to-point protocol. It's a data link protocol used to establish a direct connection between 2 nodes. So remember that. A point-to-point protocol, a data link protocol that is used to establish a direct connection between some 2 nodes. For WANs, the physical layer implementation will vary based on the distance of the equipment from each service, the speed and the type of service. You can use serial connections to support WAN services such as dedicated lease lines that run a PPP or frame relay. ISDN would offer, dial-on-demand connections or dial-up backup services. An ISDN basic rate interface is composed of 264 kilobits per second bearer channels, there's B channels for data, and 1 delta channel at 16 kilobits per second used for signaling and other link management tasks. As the demand for residential broadband high-speed services has increased, typical residential DSL service can achieve T1, E1 speeds over the telephone line. For long-distance communication, WANs use serial transmission. This is a process by which bits of data are sent over a single channel. This process provides reliable long-distance communication and the use of a specific electromagnetic or optical frequency range. For a Cisco router, physical connectivity at the customer site is provided by one of the two types of serial connections. The first type is a 60-pin connector. The second is more compact smart serial connector. If the connection is made directly to a service provider or a device that provides signal clocking, such as a channel data service unit, the router will be a data terminal equipment and use the DTE serial cable that is shown. However, there are occasions where the local router is required to provide the clocking rate and therefore will use a data communication equipment cable. Routers are responsible for routing data packets from source to destination within the LAN and for providing connectivity to the WAN. Within a WAN environment, the router contains broadcasts, provides local address resolution services such as ARP and RARP, and may segment the network using subnetwork structure. In addition to determining the cable type, it is necessary to determine whether DTE or DC connectors are required. The DTE is the endpoint of the user's device on the WAN link. The DCE is typically the point where responsibility for delivering data passes into the hands of the service provider. So note, user equipment and service provider equipment. Interfaces on routers with modular serial ports are labeled for port type, slot, and port number. To connect a router for DSL service, you need to use a phone cable with RJ41 connectors. For DSL works over standard telephone lines using pins 3 and 4 on a standard RJ41 connector, which is shown. To connect a router for DSL service, you use a phone cable with RJ11 connectors. The DSL works over standard telephone lines using pins 3 and 4 and on a standard RJ11 connector. The cable used between a terminal and a console port is a rollover cable with RJ45 connectors, and you can see a diagram of that. This diagram shows you a rollover cable, also known as a console cable, and has a different pin out than the straight-through cable or crossover cables used with Ethernet or ISDN. So this is something that you should get used to if you're going to become a network engineer. You must be able to understand this and know, identify rollover cable, crossover cable, and straight-through cables. Right, that brings us to the end of this session, and thank you.